here's the rough watershed boundaries. I'll show you that in a minute. But the important part is that what goes right through the middle of it is the Keweenaw Fault. And so what I've chosen to do is really to focus on that fault and all of the things that it does, because that's really the theme of this watershed. And there's a whole lot of things about the fault that are extremely influential about the area, and so I want you to realize it. First of all, the fault divides the peninsula into two pretty much equal parts in terms of area. There's a low part, which is underlain by the Jacobsville sandstone in the south part, and there's a high part, which is underlain by the Portage Lake volcanics. Black rocks on the north, red rocks on the south. If you're not a geologist, but you notice the difference of these kinds of things, and the topography is really different. And the rivers, like the Trap Rock River, go along next to the fault. That's absolutely normal. It happens everywhere in geology, but most people don't realize this, that the faults have a profound effect. The Pilgrim River, the same thing happens. And so we have this river system that comes out of the northern part and goes into Torch Lake. And Torch Lake is nothing but a valley that happens to be filled up with water. So it's a former river valley, and it was cut in there because of where the fault is. And so the river migrates a little bit to the south because the red rocks are softer than the black rocks. And so the river likes to cut down into the soft rocks. Okay? That's what there is to it. And so that's what we're going to do, is kind of go along with the fault. And the fault is more complicated than a single line, which I showed in that first diagram. It has slivers and imperfections along it, and so some of these are shown up here. And it's not just a line that you can simplify along in this direction, but there are offshoots. So these are related sort of structures. And so this is a detail. Now you can see the watershed boundary. And you can see that the fault really does bisect the region, except for this little area up in here. Turns out there's a subsidiary fault here that changes the course of the Trap Rock River. And so just to focus on the valley, which goes down here, the Trap Rock Valley, and you can begin to see it on this topographic map. It's a really deep valley. It goes 250 feet below sea level. It's filled up with glacial material that got washed in there. But it's a deep valley, and it originated at the time that the glaciers pulled off of the Keweenaw, and they pulled off from the west to the east. So there was a time when the ice still stand was out in this region and the water was flowing down in this direction, and so it cut this deep valley at the time of the glacial retreat. That was between 13 and 10,000 years ago, mostly. Most of that erosion took place. And the valleys of all the rivers, it's kind of a blessing we have. We have big valleys compared to little streams. And the reason is there's not as much water behind it. When the ice was melting, there was a mess of water coming out. Some of the flows of the streams approached the levels of the Mississippi River during the melting of the glacier, because the glaciers were 2 miles thick when they covered the Keweenaw. And so there was a huge amount of melting that took place when the glacier retreated. And so we've got these big valleys and small streams in them, and so we don't have big floods. That's part of the reason we don't have big floods, because the valleys are plenty ample for the streams that flow in them.